Hello, I wanted to share some updates on the RGB to HDMI converter. One of it is the capability to transfer the images that you have been getting from the RGB directly to the computer, and also that the original intention was to capture RGB on 16 bits color depth, and now we added a 8-bit color depth, and that gave us the opportunity to double the resolution of the system to 640 to 240, and which is kind of something usable for the usual retro computers. So additionally to that, we are going to be sharing an application that allows to control or manipulate the RGB to HDMI converter. Well, I'm going to be sharing here the device or camera that shows how it's working the RGB to HDMI converter. So let me get this one. So right now you are seeing the Amiga computer being presented on the RGB to HDMI. As you can see on the bottom left, you can see that it's an HDMI screen, and is currently managed by the device, which is the RGB to HDMI. Now it's also connected to the USB, not only for powering but also for managing USB connection. So one of the things that we are going to be sharing is the possibility to capture the screen. So let me just minimize a little bit this, manage this a little bit here. So one of the things, well, first of all, we need to enable the USB capability, basically because we don't want USB interruptions to disturb the quality of the image. So we press the 3 buttons, and now it should accept commands. Let's just show it here a little bit bigger. So let's just move the screen to the left. As you can see, it's moving to the left. We can also move to the right or up. So the Python application is just an utility that can be improved. So it's just an initial Python application. So one of the things that is going to be sharing is the device information, the version of the system, and the resolution. If you can check, let me see here, and if we zoom this a little bit, you should be able to see that the current resolution is 320 by 240. We can change that. Basically, what we do is to deploy a new firmware version into the device. But right now, what we are going to be doing is to capture the image. Let's wait for something more nice or neat to see. Should change the capture, and as you can see on the application, it has just captured the same image. The quality is rather good, and the resolution is, well, 320 by 240. What we are going to be doing right now is to deploy on the device a different version, a version that manages 640 by 240. So I have here the, let me just change the order of this, and what we are going to be doing is using the 640 by 240 version and deploying it to the device. What we need to do is to put the device in UF2 mode. Just a second so we can share that. So basically you reset the device and press the boot button and release the reset, and what is going to be appearing on the screen, on the file system information on the computer, is that you have, let me just change this and zoom it. You're going to be seeing there an RPI RP2 identified there. So what we are going to be doing is dragging the 240 by 640 by 240 and 8 bits into the device. There you go. And it should be expected that the system to reboot. So the information that you're going to be seeing there is that the system is alive, and it's still, sorry, HDMI signal. But if we check on the application, let's put the application on top. If we check on the application, we need to put it again into the mode so it's detected. Sorry. Let's put it on top. There you go. And we put it, we enable the USB. Okay, so it should detect it, and the resolution now is 640 by 240. That's the new resolution, and we can capture again the image. Let's just wait for something more interesting to see. Let's wait. Or we can in the meantime capture this. There you go. We can capture again. There you go. Let's just change the application on the Amiga so we can see how it affects the color density. So the blue and the red are a little bit shifted. That is expected. So now what we're going to be doing is put it to see the video. So as you can see, the levels are reduced. So we have only 8-bit of color density. So the camera is taking less color than the actual ones. It's just a thing of the camera. So they are a little, these colors are a little bit more identified, the red ones as an example. And let's just change the firmware again to use the other one, the 320 by 240, but with 16 8 bits, 16 bits, sorry. Just a sec. Let's put this here and wait. Let's put it in on the boot mode. Reset, press boot, release, and let's drag onto the RPI. Let's just move this a little bit here, and let's put the other one, the 16-bit version, into the device. There you go. So as you can see, there is more colors because we have 65,000 colors approximately. And let's capture this. So let's again enable USB and capture. Let's see, let's move captured image here and the application here and capture. Okay, as you can see, more colors, and the capture is working, detecting either if it is 8-bit or 16-bit. So thank you, that's it.